yourself first. Are you the mic right there?
This one works as well. Okay. Great. So my name is Peter Sieber. I'm with HEMA. Concerning my professional background, I'm engaged with functional safety since, I think, 1988. Since end of the 90s, I'm actively engaged with the development of IEC 61508, 61511, but also since 2006 now with IEC 62443, plus some site standards dealing with engineering processes.
Thanks. My name is Prasad Guteti. I represent Honeywell Process Solutions. I'm based out of what they call the Safety Engineering Center of Excellence out of the Houston, Texas office. We do engineering for safety systems of our own products, and if required, others too, which we don't like too much, but we do. And I personally get involved a lot in the front end of doing risk analysis, which you heard of, LOPA, so on and so forth, and also how we in Honeywell, as well as if customers need guidance, how to manage a safety lifecycle.
Hello, my name is Iwan van Beurden, and I'm a CTO, Director of Product Development at Exeda. I'm responsible for our Excellentia software. It's my baby. I am a member of the ISA 84 committee, as well as the 61511 committee, where I represent the US. The director of the ISA Safety and Cybersecurity Division, ISA Fellow, and I think that's it.
Well, good morning. My name is Luis Duran. I'm with ABB. I'm based out of Houston, Texas. I'm globally responsible for the ABB safety offering within the 800XA product family, and also the security of the product portfolio on the Control Technologies group.
My name is Eddie Habibi. I'm the founder and CEO of PAS. You may have seen my name on a couple of books on high-performance operator graphics and alarm management best practices. Dedicated the last 25 years of my life and our company's mission to save lives. The gentlemen on this panel have done the same thing. It is the most important thing that any of you do. If you think of it that way, it's a great mission to be on. And the one thing that I can say that I've learned is every incident I have ever come across is preventable. Incidents happen because we make mistakes. Human error is the #1 cause of incidents. And with that, I think we have a good conversation starting here.
Hi, name's Gary Williams. My role today is primarily cybersecurity. Worked with safety in the past. In fact, I have a patent for a wireless safety system. The drivers today for us is we've been pushing both publicly and also with our clients that cybersecurity and safety need to go hand in hand. The synergy between the cultures, between safety and security is immense. With the HAZOPs, the LOPAs, the risk and threat assessment, gap analysis. And what we're finding is that cybersecurity is now also driving the review and the evolution of safety. So as you've seen with 61511 and 61508, security is now part of the safety standards.
Okay, and then Scott's at the end. He's already introduced himself. So any questions?
Actually, I have a two-part question. I'm Stuart Maddock from MIT. The first one, it was a short one, is a colleague of mine at MIT, Nancy Levson, developed a methodology for accident prevention called STAMP. I don't know if any of you are familiar with it. Just curious how widely used it is in industry. I guess not. I spoke on Monday regarding cybersecurity, and I think there's a lot of overlap. The comment regarding being preventable and so on. So the obvious question you have in both cases, both in accidents and in cybersecurity, is why doesn't management do it? And I think the argument I hear from managers, well, you can do 10 things. How do you know it isn't the 11th thing? How do you know it's not the 12th thing? So I can never be completely sure, so how do I know how far to go? So I'm curious, what can be done to change the mindset of upper management?
Okay, Scott.
Well, I think the old adage of walking the talk. I think knowing from a upper management standpoint, supporting this type of concept organizationally, identifying individuals or wholesale disciplines that have the focus of process safety. And as Mark had alluded, when you mention somebody as a safety engineer, when it comes to manufacturing operations, usually it's either machine safety or hard hats, safety glasses, personal protective equipment. The concept of process safety in certain arenas is often misunderstood. But from an organizational standpoint, having the organization put in place so that you have properly trained individuals and the support of the training and the long-term care and feeding, if you will, of those individuals, of those disciplines, and then making sure that they stay engaged in the day-to-day operations and making sure that that falls into place. Again, unfortunately, we are coming up against some things that as, you do development of new processes, new technologies, there are unknowns. But until you can collaborate in these types of forums and learn what others are doing to the point of achieving overall safety in industry, then you're just going to move along as best as you can. But you really do want to take advantage of safety in general across the industries and be able to learn from peer companies. Okay. And I think if you talk, for the most part, with peer companies, they want the industry to be safe because that's how they make money. And so from a safety collaboration standpoint, there are a lot of organizations that are willing to have conversations about those kind of things.
Okay, so panelists are raring to go on this question. Let me let Eddie go first.
I think the question was, how do we get the attention of leadership and leadership support? How do you have the attention of leadership when it comes to production and profitability? They have a dashboard on a daily basis. They see where they are. I think the most important thing you can do for your leadership is to expose them, if not on a daily basis, but on a weekly basis, or by exception basis, a report of the state of their independent protection layers. This is a dashboard managers use. Dow is an excellent player or a practitioner of that. We were involved with them from the early 2000s where they had developed a benchmarking approach on alarm management. They were getting status on their alarm management systems at individual units. And what was really interesting is that the site manager would have the bottom 3 units supervisors in his office at the end of the month explaining why their metrics were the lowest. It goes back to what Peter Drucker said. You can't control what you can't measure. You have to measure the performance, the availability of your safety systems and report it at the highest level, at the executive level.
Well, I mean, somebody stole my thunder, but that's fine. I was about to go, but about question 1, right? Do we really understand what can go wrong? And I think that when we want to get the attention of management, we need to convey that what can go wrong in a measurable way that they can relate to. So as Eddie was saying, that I think is critical. In addition to that, I think it's a matter of, again, measurements. And, yeah, we can quote Peter Drucker, but again, it has to be something that is not a one-time event, it's not a weekly event. It has to be a continuous presentation of what, kind of a live dashboard, because safety is not a one-time event, security is not a one-time event. We need to, it's another performance metric, same as the production of the unit or the downtime of the unit. So we have to, basically present the material, the information in a way that is actionable at that level, that can get the attention of the management at that level to ripple down the organization to really take the measures that are required to protect and provide the risk reduction that is required.
Okay, Peter?
Yeah, from my point of view, what is really important in order to gather management attention is that we are utilizing the right language. We as safety experts tend to be pretty technical and pretty focused on technical details. And I think there is a couple of fundamental things that needs to be communicated clearly, such as accidents and incidents do not happen, they get caused. This is one very important aspect. And the other important aspect I would like to highlight here is that quite often we are engaged in discussions around the cost of safety. And from my point of view, there are no cost of safety. There are only cost of unsafe situations. And I think this is something that need to clearly be outlined to management. And typically, my experience is that these messages clearly can be understood.
I would just like to add something which has worked for me. In Scott's slides, you noticed he said risk is nothing but consequence into frequency of occurrence of harm. The first question I would ask is, what is the frequency of a meteor hitting this room in which we are standing, sea level guy? It's very low. It's low, but it's not zero. Risk is never zero. So there's always an inherent risk how many ever safeguards you have. So you want to reduce the frequency of occurrence of harm. And for that, if you have the risk, you saw the cost in the slides, the cost of safeguards is minuscule compared to the cost of the actual hazardous event. And these, again, C-level guys understand dollars, so that's another way to project it.
So we heard some solutions as to how to get management involved, which talk about, we need to provide them information that they understand and that they see actionable tasks coming out of. In some cases, that won't work. And the only way to get management attention, unfortunately, is to have an accident. And that may sound a little bit crazy, but we've had many customers who didn't want to talk functional safety at all because they've never had an issue in the past. And they didn't believe in all these probabilistic approaches and probabilities of failures and initiating event frequencies. Why would we need to look at that? Everything worked for us in the past until something goes wrong, and then they're on the phone. So I'm not wishing anybody accidents, but I think if we try to learn from Buncefield, if we try to learn from the Caribbean Petroleum event, showing actual issues to management, having the simple lunch and learns may be an initial step to get their attention. And then we can talk about how we present them information that they can act on.
I agree with everything that's been said. However, I would also like to see a change in culture. I think there's too much set and forget. And with the HAZOP, the LOPAS, the risk and threat assessment gap analysis, as we see these events taking place in industry, it should be used as a driver for exercises, for auditing, for cycling, because I don't think we do it enough. Too many people become complacent.
Make sure you're talking into the mic.
Okay.
Hi, my name is Ron Sisko. I work for a power and water utility in the state of Arizona. One of our core safety principles is that safety trumps production, and I can honestly say for the last 5 or 6 years we've actually lived it. But a consequence of that we've seen happen recently is that some people joke about making t-shirts that say feelings trump production. And I wonder what you guys would think about balancing a calculated amount of risk for production versus living that culture of safety. And then I have one more question for Scott in particular, and that's have you had any sightings of the Mothman at any of your chemical plants there in West Virginia?
No, we revoked his security pass into our site, so he just doesn't show up anymore.
take a shot at answering his question, first question?
Well, again, there's always a balance of, acceptable risk, consequence, and that's part of setting the culture and setting what is acceptable, at the corporate level, at the business level, at the site level, whatever product that you're manufacturing. A lot of it is it even depends on the location. I think if you keep things in perspective as this is our license to operate, maintaining a safe operation, then I think you can get an effective balance in, the types of investments that are expected and the return in that we can continue to operate. We have to be able to operate safely. And what may be an acceptable risk for some organizations, depending on what they're manufacturing, depending on their location, may not be acceptable to others. So it's unfortunate that everybody has their own level of acceptance and their risk criteria. But ultimately, the first step is to identify that, make sure that everybody buys into it, and then go from there.
Let's go in order. Make it easier on me.
Easier on you, all right?
So
Okay, and I totally agree with Scott. Consumption of risk is down to a site level. It's not something that can be applied across the industry, etc. As we've started measuring, again, regrettably, and going back to cybersecurity, as we've been measuring the risk and the threat, and we work closely with our safety, it's an opportunity to review, but I don't think there is a single metric or approach that you can do. It is site-specific, and therefore the ownership is also site-specific.
All right, what I wanted to add to the answer before is there's obviously a human element that we need to take into account, right? So, and it's part of the answer in the question, do you know your role, right? The question number 4 that Mark and Scott put out. So in that definition of knowing your role, I mean, everybody in the organization has a role to play to make the organization safe, same as everybody in the organization has a role to play to make the organization secure or to make the organization productive. And in that knowing your role, from the electrician, the technician, everybody, is not left to the safety engineers. It includes management, includes everybody in the organization. So that have to fit into this cultural transformation to drive towards a safer behavior. And that includes learning from the lessons of others and how to bring that into account into your own self-analysis of the situation to improve over time.
Yeah, just a little bit to add to that. In addition to knowing your role, know your risk. What are you exposed to? If you make certain decisions to continue to operate after a transmitter fails in the safety function, know that you lost your protection. Doesn't mean that there's going to be an incident the next minute. Could be fully safe, but know the risk that you're exposed to, and so that you make informed decisions.
I would just add to that. One is you knowing the risk as the operating company, but the people outside your fence don't know what you're doing. So it's again your responsibility to make sure that people outside the fence are protected in the event something goes wrong inside. It's exactly like the air crew in an aircraft. If something goes wrong, we are all sitting there like dumb people, not knowing what to do. If the A crew also doesn't know what to do, then you are in danger. So safety culture is not just inside a company, it's also making sure that people outside the fence are protected in a way because of your safety culture.
Yeah, I think one of the dilemmas for all of us as engineers is that there is no absolute value of acceptable risk. What is acceptable or what is not acceptable simply is depending on the individual constraints, is depending on regional constraints. And just to give you an indication, if you look at China, the amount of people killed in public traffic in China is equal a fully boarded Boeing 737 aircraft per day, right? But nobody cares about it because it's publicly accepted. And we can find similar things in other areas as well. And here the only thing we can do is we need to make sure that there is an understanding that there is something like a tolerable risk, and this tolerable risk for each individual operation has to be defined.
Okay. Hi, I'm Joe Weiss. I have a shameless plug for tomorrow morning. We have a session at 8:30, and it's dealing with the lack of security and authentication in all of our level 0 and 1 devices. In other words, all of your sensors, actuators, and drives. Everybody here is talking about cybersecurity and knowing where you are. But when you start at the very bottom and there's no security in those devices, we have a new working group within 99 to look at what do we do with the 62443s, because these devices can't use the security that's in the 62443 standards. And we've also looked at 84, 61.511 and NAMOR 163. 01 really isn't addressed there. So I'm making a plea that we need to, if you're really looking at this, this is where safety is. We really do need to start looking at 01.
Can I make a comment on that?
Yeah, sure.
Joe Weiss has been an advocate of providing security for level 0 and level 1, and I want to echo that. I think everyone on this panel comes from a controls or safety systems background. And what Joe has been evangelizing is absolutely necessary because we have a flood of IT security providers who have come in to rescue us on the OT side without the realization that the actual risk comes from where digital meets physical. What's going to cause an accident in the plant is not stolen information. It is moving the wrong valve at the wrong time, shutting down the wrong pump at the wrong time, moving molecules from one place to another place where it's not supposed to go to cause harm. And I also urge my friends here on the panel to start paying more attention on securing that level 0 and level 1, both from an original design standpoint as well as solutions that provide a complete inventory of that level 0 and level 1 and beyond.
And Joe, I agree, but the addressing cybersecurity at layer 0 has already started. We do have devices with an embedded device, Secure Assure certification, but it's not something that's going to happen overnight. We have to evolve this. So the way we address it today is while we evolve to get certified interfaces, the ISA 99 segmentation, the use of zones and conduits, we have to come up with other points of mitigation why we evolve our products to meet the new criteria that's coming out. But we as vendors are addressing it, and we do have products with security built in at layer 0.
That is really good, Gary, and I really admire Schneider, ABB, Honeywell, and others for addressing that in new systems that are coming out. But you have about $500 billion worth of assets, automation systems out there with instrumentation from 20, 30, 40 years ago that do not have that level of security. How long will it be before you replace all of those old systems with inherent design, secure design in place?
Yeah, if I'm allowed to comment on that, I think, in fact, this correlation between safety and security is one of the major important aspects we need to cope with at the moment. And from my point of view, I would like to point out that we are way beyond the point where we do not know about the risk and where we do not know, where we do not do anything against it. But the issue here is that we have the situation that there is a wide range of installed devices. And if we would just rely on that something new has to be developed and that every product has to comply with certain security recommendations, that also will mean that all the existing installations have to be replaced. And I think at the moment it's simply not realistic to believe that the operating companies will be able, just because we have a security aspect to be considered now, to replace all existing installations. So long story short, that does not mean that we are not able or not willing to do something against it. But at the moment, we have to come up with solutions that, on one hand side, taking into consideration what are the security capabilities of the product, and on the other hand side, what can be done in order to protect incapable products that may be existing in our installations. And only if we can coordinate both activities and both strategies in an appropriate fashion, we will have a secure and economical solution for this kind of things. What is important from my point of view is that this situation will be with us for at least another decade, because this typically is the length of the life cycle we have to expect for the automation equipment that is used in process plants. So all in all, from our point of view, I can say we are well aware of that. We are dealing with that more or less on a daily basis, but it's much more than just having the recommendation that product development has to be changed, product design has to be changed, and new products have to be developed.
And I'd like to add something else as well, Joe, is that although we as vendors, we're trying to get the cybersecurity built into the device itself, we segment it in accordance with the standards. But the biggest threat to us are the people. If those people are not educated for the value of what we put in place and how to use it correctly, it's of no value whatsoever.
I just want to cite the incident, probably the most infamous incident we just had, security incident we had, and I really want to commend Gary and his team at Schneider for jumping on top of that Trisis security incident. Fantastic response, by the way. The issue there is that when executives from companies across the oil and gas, power, and other industries ask the question after an incident like that, do we have any of those systems, the one that was just attacked, the vulnerable one? CISOs can't answer that question because they don't have an understanding of what they have in their systems. I was at S4 conference last month in Miami Beach, and I had one of the CISOs from one of the oil and gas companies share the story with me that he was asked by one of the executives, how many do we have those systems that were affected by Triton? He says, I have no idea, let me find out. He sends a message to his automation people at sites. The message comes back, yeah, we have that system at 4 of our refineries. Well, that system, which, by the way, was the most popular safety shutdown system, was at all of their refineries because it was the standard. They had it at over 12 refineries. So not knowing what you have is going to come to haunt you. And basic inventory is the starting point.
And seeing that it's been brought up, there's a lot of lessons to be learned on the incident that took place last year. The reason why Schneider decided to go completely transparent on this, it's not about us. It's not about finger pointing. It's not about the failures in the adoption of security on this particular site. This is an industry problem, and we as vendors and clients need to work together on how to address it. The attackers in this case had unlimited resources. They had an intent. We don't actually know what their final intent was, but it's a wake-up call, especially when you come into safety. No way should anybody be able to reach a safety system from outside. So, Joe, when I said to you earlier on, it's not just about the equipment, it's people. If people do not take security seriously across the whole infrastructure, then of course your safety is also going to be at risk. So for us, it's an industry problem. We're not going to stand here and talk about who did what, where, when. We need to come together and make sure that our culture can stop those hackers from getting to us. Make it as difficult as we can.
Okay, I think we've talked enough about that.
Sorry, if I can add something.
Yeah,
Mark,
I want to
before
go
we move on.
Everybody wants to add. I still got more questions.
I think
Yeah,
Louis
15
has something good to
But
say.
there's one thing that I think is very relevant with this aspect of the people, and has to do with your slide on the maturity level of the industry, because that goes back to where we are in safety, where we are in security, and how the organizations are understanding their own, or having or forming their own views on the subject. I think that there is an issue of maturity that we as an industry, as was said before, have to address, and it's not one or the other. We all have to address it.
Very quickly, I'll add to this. I always believe in the mantra called the 3 Ps: people, product, process. Okay? All 3 have to be strong. If your product is great, let's say I tell my teenage daughter who is just about 13, hey, go and drive the BMW, the ultimate driving machine. Well, the product is strong, but the people are not. And do you have the processes? Are they licensed for it? Do they know what they are doing there? So you have all the legacy instruments. Yes, they are, because process automation came much before internet. Now it is up to us through processes and people's knowledge how we are going to protect that while this is being phased out.
Okay, I want to get to this fellow's question. Bob?
Yeah, good morning. My name is Bob Whitaker. I'm with Shell. So thank you for the presentation, Scott and Mark. My question is related to the operations and maintenance phase of the process safety management lifecycle. Scott, you mentioned proof testing, and I would certainly agree with the importance of that as an element of your process safety, functional safety system. What we find is that as important as it is, it's also a fairly costly maintenance activity. It is, in fact, sometimes occasionally leading to nuisance trips in our plants and operations. And at the end of the day, it's periodic, so it's not online all the time, right? So I guess my question is to Scott and the panel, so what are some of the best practices and maybe technologies out there on the horizon that you can envision that would help us monitor the effectiveness of our barriers in real time, all the time, so that I could say, my process safety barriers are effective, and I know it all the time.
We have recently started putting some monitoring metrics in place. As Eddie had mentioned, a lot of the underlying information around this conference is digital data, big data, analysis of the data. Well, one of the things that we are starting to roll out to some of our operating facilities is being able to extract the data from historians, from our automation systems, monitoring what's happening with our alarms, what's happening with our events, what kind of interventions are our operators having, are they putting things in bypass, are they putting things in manual, trying to analyze those things and roll the information up into a concise, simplistic view in the form of a dashboard so that you can monitor the health of your protective systems. The challenge isn't so much gathering the data as it is knowing what data to gather and how to identify the importance or weighting factors of that specific data as it applies to protective functions. You may be taking credit for a particular alarm, or obviously a SIL 3 function has to be designed and operate at a much higher integrity compared to a SIL 1. So you're going to have more weighting associated with the final elements and the sensors with that design. From a design standpoint, we take things into consideration as far as redundancy or diverse instrumentation. Based on that, based on industry data, based on operating experience, we have been able to, if you will, sharpen the pencil and calculate extended proof test intervals. In the case of redundant sensors, maybe we'll stagger the testing. The implementation of the voting logic, you can do certain things that if one particular sensor in a redundant configuration is put in bypass such that you have a maintenance crew doing your periodic testing on that, then you can do some smart things with your logic to prevent an unintended trip if an operator accidentally tries to put a redundant sensor in bypass. So there are things that you could do around your automation design. Get some information based on your operating experience to help extend some proof test intervals, things like that. But ultimately, there's always that risk. Anytime, you know, and we've talked about it with the other panel members, mentioning the human intervention associated with it, which unfortunately is a lot of root cause results in some of these incidents. You know, putting in place redundancy, smart sensors, online diagnostics, those kind of things, that could certainly drive the direction of extending proof test intervals and making sure that things are working. But ultimately, you want to be able to monitor the health and make sure that everything is operational.
Okay, I'll start with Peter and go down.
Yeah, well, from our point of view, the situation is such that, in fact, the technology we own is allowing us to do lots of extended diagnostics, starting with things like gathering online information from smart devices that may be installed in the field via doing things like partial stroke tests for the actuators, doing automated testing of software and all these kind of things. And also, of course, analyzing what's going on in the process. But from my personal point of view, I think we would do good in order to be a bit careful with what we're adding to the safety systems. Because all this marvelous function may provide additional information to us, but we have to keep in mind that the complexity of the systems we are designing by implementing all these things grows up exponentially. And thinking about the human factors, I believe that limiting the complexity of our safety systems also is an important aspect we need to look at, because we actually already are at the point where it is a bit doubtful whether the operators who need to cope with the technology we implement really are able to understand what are the functionalities implemented. So yes, there are a lot of things we can do in order to improve reliability, but we have to be a bit careful not to overcome certain limits, because then the overall reliability will drop off.
Just to continue what he said, in the safety life cycle, you have the analysis and the implementation phase, which is usually probably a max of 2 years. But the operation and maintenance phase goes on for probably the life of the facility, which is about 25 years, as an example. So you need something smart sitting there to tell you how your instruments are doing. Are they okay? People usually say a KPI is when my safety system had a demand. Actually, I see it the other way around. You want to know, are you close to a risk where you're going to have a demand? So that, if, for example, you had a BPCS interlock which failed, that means very surely you're going to have a near miss on your safety system. That may have a demand. You could keep counting the number of demands you had, but more importantly, you want to know how close are you getting to the risk. And we have all the data sitting there. You know, the data is all there in the historian. It will tell you how close you came to your high alarm limit, exactly as what they did not do in Buncefield. They knew it was coming close to the high. You don't have to cross the high to know that you had a demand. If you're coming closer to it, then you should probably be able to act and do something. So we see a lot of analytics out there with all the data sitting in the historian, which we can make use of in the O&M phase to make it more reliable.
So proof testing being just one of the many activities we need to do during normal operation to keep our safety instrumented systems safe. And Scott already alluded to it, and Peter as well. Now we can add partial stroke testing. We can do all other kinds of application level diagnostics. We can do deviation alarms to see if transmitters have a frozen output. In the end, every time we add a diagnostic, in order for us to take credit for the diagnostic, there needs to be an action associated with it. And that action could be transition to the safe state, which would probably not be what you want. You want to be able to continue to operate, or have a maintenance guy go out there, or girl, sorry, and fix the problem. The latter may sound very enticing, but it also means that we now need to have adequate crews on site to support all these additional alarms. They need to be knowledgeable about these alarms, and let's say that we can train them well, but it also means that there's additional cost of maintenance people on sites. And the typical trend we see is that we're reducing the number of people on site, saving cost, having a guy go out to do proof tests with 3 sheets of paper for a week, and he can maybe get the first sheet done, and then he gets a new set of 3 sheets for the next week. Adding all the extra diagnostics may be very good, and we can do wonderful calculations about it, but we need to realize there's additional responsibilities that come with that, and the complexity that we add to our systems may backfire. So if your proof tests cause a lot of spurious failures, then maybe the right approach will be to really understand what are you doing in your proof tests, what is necessary in order to detect those failures that are not detected during normal operation, and is there ways to be less intrusive in your overall process and prevent those spurious failures.
Let me try to answer at least my perspective in a brief form. So you asked about tools on operations and maintenance, and without adding complexity or even modifying what is installed in the field, using basically the smarts of all this digital transformation that we've been talking about for the last few days, there are ways in which you can bring that information into your operational dashboard, and it doesn't need to increase your crew on the site. It can be even monitored remotely, and then the crew is dispatched when and if needed. One mechanism to do that, you can create different ways of, mapping the situation in the field, taking into account either if a SIF or if the safety function is bypassed, if there is a failure in one of the devices, and that information is available on the, not necessarily or not only on the safety systems, it's also available on the operational displays for the operator. And we don't want to create more alarms. The operator is already overwhelmed with information that they need to act on, right? So I read the book. So not everything is an alarm. We need to really make the actionable element to those that have to take the action. In this case, that information might be something better suited for the maintenance crew that have to request the permits to really go and take the corrective action. So in short, there's operational displays and mechanism to bring that information to those that have to take action, and not going to add any commercial to that, but we can talk about it after.
So I know this is a really, really exciting session. So I'm going to add a little flavor to it. Bob, you are an automation guy, and you'll appreciate this. Remember the graduate, Dustin Hoffman? The advice that he's given at that time in the 60s was, son, plastics. Well, or today it's automation. You really want to manage your safety systems, you have to leverage automation. Almost 99% of safety system engineers I've come across are some of the best automation folks. We worked with your upstream group about 5-6 years ago to develop a method for monitoring boundary management basically, that starts with your operating envelope, normal operations, alarms, safety systems, and beyond. If you can manage that and you can automatically capture the events after an incident and generate the report that you need to show that your trip system worked on demand, I think you go a long ways of making it happen. Relying on people to do the right thing with the right procedures is not the answers. We're all control engineers, for God's sake. This is a data management issue, a data analytics issue. And it's not a big data issue. It is unique, complex data analytics. So I urge the team to take a look at tools that are already out there to automatically capture the safety life cycle of your system and provide it in dashboards that are easily consumable. And Scott, we got something to talk about after this meeting.
I'd like to add one comment, and there's a trend at the moment, especially in oil, gas, petrochemical, for data, data, data. Let's capture data from everywhere. But where safety concerned, I get concerned, because if the idea is that we can now capture data from field devices that will prevent or reduce the amount of hours that the human being goes down there to check that, we end up with a lot of data. You need skill set to get value out of that data, and without it, you become complacent, and at the same time reducing the human interaction where your risk actually takes place. So if you're going to go down the data route, please do it cautiously.
Okay, so we're 5 minutes over, which I wasn't expecting, but thank you guys for helping out.
Good question.